Ever wondered how your body instinctively reacts to a sudden fright, or how your heart rate slows when you're at rest? That's the work of the autonomic nervous system, a vital player in our bodily functions. Stay tuned as we unravel the secrets of this fascinating system. The autonomic nervous system, an unsung hero, governs our body's involuntary responses. It's like an invisible puppeteer, pulling the strings behind the scenes, regulating functions that keep us alive and well. From the beating of our hearts to the digestion of our meals, the autonomic nervous system, or ANS for short, is always at work. Now, the ANS isn't a one-man show. It's divided into two main acts, if you will, the sympathetic and parasympathetic nervous systems. Imagine them as two sides of a coin, each playing a vital role, but with different approaches. The sympathetic nervous system is like the adrenaline junkie of the body. It's all about fight or flight. When you're in a pinch, it ramps things up, increasing your heart rate, dilating your pupils, and preparing your body for action. On the flip side, we have the parasympathetic nervous system. This is more of your rest and digest kind of guy. Once the danger has passed, it steps in to calm things down, slow your heart rate, constrict your pupils, and encourage digestion. Together, these two systems work in harmony, balancing each other out to ensure your body responds appropriately to whatever situation you find yourself in. Their communication is facilitated by a cast of neurotransmitters and receptors, which we'll delve into later. Now let's dive into the workings of these two divisions. The sympathetic nervous system, your body's own fight or flight response mechanism. Now let's dive into the details. The sympathetic nervous system, often dubbed as the body's emergency system, is all about preparing the body for action. It's like your personal superhero stepping up when you're in danger or under stress. However, this superhero doesn't wear a cape. Instead, it communicates through neurotransmitters. Neurotransmitters are these incredible chemical messengers that transfer signals between nerve cells. In the sympathetic nervous system, the primary neurotransmitter is norepinephrine, sometimes referred to as noradrenaline. It's this little molecule that gets your heart pounding when you're excited or scared. Norepinephrine doesn't work alone, though. It communicates its messages by binding to specific receptors on the cells it targets. These receptors, called adrenergic receptors, come in two main types, alpha and beta. Each type has a unique role in the fight or flight response, influencing different physiological changes. When norepinephrine binds to alpha receptors, it typically results in constriction or tightening of the muscles. Think about how your pupils dilate in low light. That's the work of alpha receptors. On the other hand, when norepinephrine binds to beta receptors, it often leads to dilation or expansion. This is why your heart rate increases when you're nervous or excited. As you can see, the sympathetic nervous system is a complex and beautifully orchestrated system. It's not just about running from a lion or facing a tough situation. It's about your body's ability to respond to changes in the environment, to prepare for action, and to keep you safe. It's about survival. So the next time your heart races or your palms sweat, remember it's your sympathetic nervous system working hard to prepare you for whatever comes your way. It's your body's way of saying, "I've got this." Next, we turn our attention to the calming counterpart of the sympathetic nervous system. Meet the parasympathetic nervous system, your body's rest and digest system. This is the part of your autonomic nervous system that works like a maintenance crew, ensuring everything runs smoothly when you're at rest. It is the unsung hero that helps you relax, conserve energy, and keep your body running like a well-oiled machine. The parasympathetic nervous system is like a symphony conductor, orchestrating a variety of functions within your body. It slows your heart rate, lowers your blood pressure, and stimulates digestion, just to name a few. It's all about maintaining balance and harmony, allowing your body to recover and recharge. Now let's talk about its neurotransmitters and receptors. The primary neurotransmitter of the parasympathetic nervous system is acetylcholine. This chemical messenger is responsible for transmitting signals from the parasympathetic nerves to muscles, glands, and other nerves throughout the body. It's like the conductor's baton directing the body's responses. Acetylcholine interacts with two types of receptors, muscarinic and nicotinic receptors. Muscarinic receptors are found in many places throughout the body, including the heart, where they help to slow heart rate. Nicotinic receptors, on the other hand, are primarily found in the nervous system and muscles, where they help to stimulate muscle contractions and other responses. But it's not all about acetylcholine. Other neurotransmitters such as nitric oxide and vasoactive intestinal peptide also contribute to the parasympathetic nervous system's functions. They play a role in everything from relaxing smooth muscles to stimulating the secretion of saliva in your mouth. It's a complex symphony of chemicals and responses, all working together to keep your body in balance. So as you go about your day, remember the parasympathetic nervous system and its remarkable work. It's the system that lets you chill out after a long day, helps you digest your favorite meal, and keeps your heart ticking at a steady rhythm. It's a crucial part of the autonomic nervous system and an essential component of your overall health and well-being. Having understood these systems separately, it's time to look at how they harmoniously work together. Like two sides of a coin, the sympathetic and parasympathetic systems complement each other. These two systems are the yin and yang of our body, constantly working together to create a balanced internal environment, a state known as homeostasis. Imagine a seesaw. On one end, we have the sympathetic system, our body's fight or flight response, kicking into gear when we face stressful situations. It accelerates our heart rate, dilates our pupils, slows digestion, and prepares us to either confront danger or run away. On the other end is the parasympathetic system, the rest and digest response. It springs into action when we're calm and relaxed, slowing our heart rate, constricting our pupils, and stimulating digestion. It helps the body recover and conserve energy after the sympathetic system has done its job. Now, this seesaw is never static. It's always in motion, with the sympathetic and parasympathetic systems working in tandem to achieve equilibrium. When one system is dominant, the other takes a step back, and vice versa. This delicate interplay is what keeps our bodies functioning optimally. For example, when we exercise, our sympathetic system ramps up to increase blood flow to our muscles. But once we're done, the parasympathetic system takes over, calming the body down and facilitating recovery. However, this balance can be disrupted. Chronic stress, for instance, can cause the sympathetic system to be constantly activated, leading to health issues like high blood pressure and anxiety. On the other hand, an overly dominant parasympathetic system can result in low blood pressure and lethargy. So maintaining this balance is crucial. And it's not just about physical health, it impacts our mental well-being too. Techniques like deep breathing and mindfulness can help regulate this interplay, promoting both physical and mental health. Now that we've covered the basics, let's delve into the signal transduction mechanisms in these systems. In our next segment, we'll explore how these systems communicate with our bodies at the cellular level, with neurotransmitters and their receptors playing a pivotal role. So, stay tuned for a deep dive into the fascinating world of the autonomic nervous system. Signal transduction mechanisms, the unsung heroes of communication within our bodies. These complex processes are the lifelines of our autonomic nervous system, ensuring that the right message reaches the correct destination at the perfect time. Imagine signal transduction as a relay race. The neurotransmitters are the athletes passing the baton, and the receptors are the teammates waiting to receive it. When a neurotransmitter, such as acetylcholine or norepinephrine, is released, it carries a specific message from one neuron to another. This message or signal could be anything from increase the heart rate to contract the muscles. But how does the neurotransmitter pass the baton to the next neuron? This is where our receptors come into play. They are the gatekeepers on the membrane of the next neuron, waiting to receive the neurotransmitter. When the neurotransmitter binds to the receptor, it's like the baton being passed in our relay race. This binding triggers a series of biochemical reactions inside the neuron, which is the actual signal transduction. This process can lead to a variety of outcomes, such as the opening or closing of ion channels, activation of enzymes, or changes in the cell's metabolism. It's fascinating to think about how this process happens thousands of times per second in our bodies, isn't it? The mechanisms of signal transduction are incredibly intricate and efficient, ensuring that our bodies function smoothly. The signal transduction mechanisms of the autonomic nervous system are vital for our survival. They allow our bodies to respond rapidly and appropriately to changes in our environment, whether it's running from a predator or simply digesting our food. Understanding these mechanisms not only sheds light on how our bodies work, but also provides insights into how we can treat various diseases. By targeting specific neurotransmitters and receptors, we can potentially control the signal transduction process and thus influence the body's response. With this, we've covered the essentials of the autonomic nervous system. So, to revisit what we've learned today, we've explored the autonomic nervous system, delved into its sympathetic and parasympathetic divisions, and understood neurotransmitters, their receptors and signal transduction mechanisms. A complex yet fascinating journey into our body's silent operators. Subscribe for more because you won't find me later.